your mind during the presentation, you can definitely ask me in between, also at a later date.
Yes, sir, sure.
So just 1 minute, I'll just share this.
Sir P, I think you have not turned on your camera. If you are okay, you can turn on your
Yeah,
video.
I will just turn on my camera also. Just one
Yes.
minute. Let me first share it.
Yeah, yeah. It's,
Just some little problem here. So can you see the camera now?
yes, I can see your.
Yes.
Yes, sir.
I'll take it to the presentation mode.
Yes, sir, please.
Can you see it now?
Mm, not yet, sir.
Not yet. Just 1 minute. I think there is some issue here because of which I am not able to. Just 1 minute.
Yes, sir.
Now is it visible?
No, sir.
Not yet, sir.
I think now it is visible. Right?
No, sir. Your presentation is not visible yet.
Just 1 minute. Okay, there is some problem here. Let me just try again.
So the same way you have to just
Yeah,
share.
I'm just doing it. I'm just doing it. Just 1 minute. I think now it will be visible. Okay.
It's still not, sir.
No,
Yes,
sir.
yes.
Ah, yes,
It's there.
yes.
It's there.
So
Yes,
welcome
fine,
to
sir.
welcome to a discussion on effluent treatment, recycle, and ZLD, which is today's topic. First thing which comes to mind is what is waste management? So it is the action and processes required to manage the waste from source to final disposal, isn't it? These are the waste management practices human being has followed for a long period. Means initially, what used to happen? Initially, wastewater used to be only sewage. So it used to be open defecation or burying far from living spaces. Then the pipelines were laid and disposal were done on the open land for these sewages. Then people started having soak pits and septic tanks. Thereon, it developed like they had a central network to transport the sewage away from rural areas. Then came the need that there is a lot of issues because of disposing of this sewage and on the land. So then construction of centralized STPs and disposal of treated sewage on land for irrigation, and then thereafter technology to meet the upgraded stringent norms, because then the norms came into picture when population increased, urbanization increased, then all these norms which have come into picture. There are government policies. These policies also helped over a period of time. Initially, the government allowed the disposal into the land or rivers, but then they said no, it is polluting the rivers and the land. Then they said you have to have a decentralized ETP and STP compulsorily. Over a period of time, then they started monitoring those by having online monitoring systems compulsory for the industry, so that, and by doing so, what used to happen is that in Gujarat started it first. They used to have online analyzers in the treated effluent disposal lines, which used to send signals to their centralized offices of government, wherein they used to analyze what are the parameters they are disposing. Are these as per the latest norms, or these are not based on the latest norms? And then whosoever used to dispose the wastewater without meeting the disposal norms, they used to be fined. They used to be given closure notices so that they can meet the norm. Policy changes with respect to water supply means there are actually most of the things started from Gujarat and West, rather South, wherein they laid the norms. Like, I can give you an example. There are companies those who have said you will not be able to get more than 10% or 5% of the water of your total water demand. Remaining, you have to manage water internally by recycling it. So initially they laid it for recycle. Then when they were giving permission for construction, installation of new, or rather construction of new factory, in that case the permission used to be given only on account of recycle and zero liquid discharge. They made it compulsory that you will be given permission only if you have treatment units and you are able to treat the wastewater and make it suitable for your processes, so that it is a zero liquid discharge plant. Moreover to that, what they used to do is there are no disposal network around that factory, so that even if they are not able to meet the norms, they can't dispose of. So that will help their production. So in turn, they are forcing the industries to have recycle and ZLD processes. What is the importance of recycle? I think those living in cities like Pune, Hyderabad, Bangalore, they understand that urbanization has increased. All these cities used to have ample water supply from lakes around the cities. But now, even in the rainy season, people are getting water by tankers. And these tankers are very, very expensive. Means there are housing societies where the people are saying to meet their water demand, they have to call tankers. So what key benefits the wastewater recycle can give? It can give the benefit not only for domestic sewage, but also for industry. It helps in conservation of water resources. It helps to reduce the discharge of pollutant into the river and lakes. What used to happen there, you must have read many times in the news, that there are certain rivers wherein fishes have died because of toxic release of wastewater by the industries, even though if they're having the effluent treatment plant, but they, on account of only saving the cost, they have discharged into the rivers. But by having the recycle and zero liquid discharge systems in the place, they will not be able to do it. And by having the recycle system, and also the government will plug their outlet disposal pipelines so that they cannot dispose anything in the rivers or lakes. It also helps in sustainability with respect to what is the industrial water demand, what is your demand in your domestic housing societies, and what is the supply. I will give you here an example. Suppose in a housing society, your water requirement is 200 meter cube per day, out of which, if your flushing water and gardening water requirement is around, you can say around 70-80 meter cube per day, that is equivalent to 7 to 8 tankers per day, and that is equivalent to around 7,000 to 8,000 rupees per day. So all these societies, government has given some benefits so that they can recycle this water, and they are also told that this is the water you have to recycle, and you will not be having an outlet line wherein you can dispose your treated sewage. It also helps in groundwater discharge. Recharge means, suppose your treated water from your STPs or ETPs is well below the norms, and if there is an ample water supplies, means you don't have a requirement in reusing it, then you can use it for groundwater recharge. It helps in availability of fresh water for agriculture. Means if the industrial water requirement reduces, then whatever the excess water is there in the canals, in the rivers or lakes, that can be supplied for agriculture purposes. It also helps in reducing chances of waterborne diseases. Means many of the industries, if they discharge the wastewater into the rivers, and if it is polluted, and if it is consumed by human beings or living beings, or rather I will say, and that can cause waterborne diseases. But even if it is recycled for non-critical purposes like flushing, for gardening, or for industrial purpose, there is no chance of spreading this waterborne diseases. And this water supply is not impacted by climate change. I mean, suppose an industry, there is a drought. Naturally, the water supply, external water supply will reduce. But in this case, what will happen is, because if your 90-95% water requirement is met by your recycle and zero liquid discharge plant, there is minimal impact on you for climate changes, because only 5% of your water, in that case, you need to have from external sources. What are the keys for sustainable waste management? It is reduce, reuse, and recycle. Means, suppose here I want to give an example. Suppose you industries are told that you have to treat the water and dispose it off. They will. It is natural that they will try to comply to only to the norms. They will not try to treat it more than the norms, so that the water quality further improves. This is only on account of reducing the cost. But when they know that they have to recycle it, they will first they will try it, reduce the waste at source, wastewater at source. I can give you an example of textile units which are there in I have seen in Surat, wherein what they do, most of the water is used for blanket washing, wherein they are sort of printing the saris. So they started treating this water to an extent which can be used for blanket washing, so that their fresh water this thing demand reduces. One thing is here important is, they also tried some practices in the production unit which can reduce the wastewater, because higher the amount of pollutant left on the blanket or in a cleaning vessel, higher is the water demand. So what they used to do, they used to clean the vessels by some dry processes. Once they clean some vessels by dry process, only a little amount of water is required to clean it thoroughly, and then again prepare it for next batch of printing. Second step is reuse. Means, whatever suppose waste is there, if suppose one particular process produces a waste, but that can be reused for some other application, in that case, that will not go to the effluent treatment plant, and in turn they will reduce the cost on the waste treatment, as well as they will be able to use this water. And the last but not the least, that is the recycle and zero liquid discharge. These are the practices for which helps in reducing the wastewater generation at source. Means, if you have some processes in production wherein you can reduce the waste at source, that means, I'm just giving an example of a textile industries, wherein if the main pollutant which is going to the wastewater treatment plant is dyes, color. If suppose you are able to reduce that color by some dry process, like the Surat unit used to do, they first used to recover that dyes from the blanket, which could be reused in the production. So what they have done in turn, they have first recovered the dyes which would have gone to the effluent treatment plant, and that would have consumed chemicals for treating it and produced sludge in turn. So on three accounts they have saved money there. One is recycle of dyes, saving of chemical in the effluent treatment plant, and less amount of water going to the wastewater treatment plants. That means reducing the capacity of the wastewater treatment plant. Use of technologies which will help in reducing the waste. Now, they also, because these things came into picture, the government enforced that you have to recycle the water. So they also want to run their business. So they thought about what is it that they can do in their production unit which can reduce the wastewater. Practices for reuse first. As I shared with you, suppose they are having a dilute wastewater. They have started using it for first wash, and the second wash can go to the wastewater treatment plant. So they have started these practices. This helped them in reducing the wastewater going to the effluent treatment plant. Then practices of facilitate recycle, means they have they have used all the practices, means they have strengthened their mass balance, and they have understood what all things they can do, so that each and every wastewater can be treated in a particular way which can be reused. Then practicing and facilitating the recycle and ZLD. Initially, people, as I have shared with you, initially they have started putting the effluent treatment plant and only meeting the norms. Then they started making the water suitable for recycle. Then they started thinking of how do I reduce my rejects which are going to evaporator, because evaporation technology, they use steam, and steam is very, very expensive for evaporation of the water. So then they started thinking how they can reduce the steam, how they can use the new technologies which can reduce their operating costs and all, so that whatever the recycle and ZLD plant they are putting in, that is sustainable. What are the benefits of sustainable waste management? These are the benefits, major benefits, which the industry looked, or the houses societies look, so that whatever the solutions are there, they are sustainable. Otherwise, if suppose after putting a technology, the textile production cost is increasing, that will have a directly impact on the product which they are manufacturing. That will become expensive, and ultimately people will not buy. So it is not sustainable. So they look for solutions which can reduce their energy bills, which can reduce their water intake bills, which can reduce waste disposal bills. Means suppose they are producing 100 meter cube per day of water, and if they are able to recycle 95-98%, only 2 or 3% or 4% they have to dispose it off. So that much only they will have to spend money for disposal. They're reducing waste management infrastructure, because they are reducing less amount of water outside. Then this helps in reducing the waste management infrastructure. In terms of, suppose all the societies, I give you an example of a domestic societies here, they are not treating the sewage at source. So what will happen is, there will be a transport network for the sewage from the housing societies to a common effluent treatment plant, treating it there, and then again there will be have to have a transport network for disposing it. But if they are able to recycle within the societies, all this network capacity will come down, or it may not be required at certain places. There is a common practice when it is discussed that recycle and ZLD. First thing it comes to the mind of many individuals, that is, it requires a reverse osmosis system and evaporation. It is not necessarily that all the recycle plant require reverse osmosis and all the ZLD plants require evaporation. Typically, these are the units or processes, you can say, which are used for in any recycle plant and ZLD plant treatment scheme. Organic removal means, first is the water needs to be treated in an effluent treatment plant and made suitable for recycle system. Many of the for many application like domestic sewage, recycle may or may not require a membrane-based treatment, or maybe a RO-based treatment, because in domestic wastewater, what they do, the expectation is treat the water and make it suitable for flushing and gardening. And for flushing and gardening, what is important is for removing BOD, COD from the water, and reduce it so much so that wherever, suppose this is stored in the society, in the gardening or something, it doesn't smell. And it can be used also for flushing. There are many industrial applications wherein, like coal pile runoff, wherein a lot of water is used for quenching the coal so that the dust doesn't fly. All that water is collected and only TSS removal is required there. In that case, what they require is only a settling tank, a filtration, and a sludge handling system. That's all. In many domestic sewage plant or industrial wastewater plant, one thing is there: water is treated, but if it is having color, nobody would want to use it. So in that case, there are polishers which are available now, which are resin based or pure coat polishers. I will share with you the details in the presentation. Or oxidation, which can remove the color from the water, and visibly there will not be any objection from user point of view. There are many industrial applications wherein only hardness reduction is required. So these are either resin-based or a membrane-based system. Yes, there are many industrial applications where the TDS is very high. Say example, 3000, 3500, it can be a cooling tower blowdown. It can be a textile wastewater treatment plant wherein the salt is used for dye fixation on the cloth. So wastewater contains a lot of salt. There, definitely you would need a membrane-based system, because in membrane-based system, that too reverse osmosis system, which can give you two waters. One is good quality water, that means low TDS water, and the other is a very high TDS water. The low TDS water, say around 150, 200 ppm TDS, can go to the production, and high TDS water goes to the evaporation. High TDS reject management. It is very, very important here because the evaporation costs are very, very high. So the practices are either use a ME or MVR or agitated thin film dryer or a pusher centrifuge for concentrating the salt in the reject. But over a period of time, now the technologies are getting developed wherein high TDS reject management is done by a high pressure RO. Means normally seawater used to be the maximum TDS which used to treat, like 60,000, 70,000 sort of a TDS. But when the reject TDS from the seawater is very high, then now it is high pressure ROs are developed so that reject quantities can come down, your evaporation requirements can come down. These are the major driving factors for recycle and ZLD plant. One is saving in water costs, recycle water quality, availability of water from external sources. I shared with you many a time, you are ready to pay, but water is not available externally. So that the major driving force for the industry is, in this case, let me go for recycle. Disposal constraint. Government has not given any disposal lines, so you can't dispose water outside. And even if it is given, the disposal point is for many companies, say 1 kilometer away or 2 kilometer away. So it involves pumping costs, it involves infrastructure costs for disposal. Then there is another driving force, because they are going to spend a lot of money in treating the wastewater. So can they generate some revenue out of it? So there are treatment processes in particular companies, those have generated some revenue from the waste, and the treatment is sustainable there. Then of course, they expect the environmentally clean solution. And other driving forces, for some cases, it is there are local issues. Even if you are able to treat the water, even if you are able to meet the government norms, even if you are able to dispose, the government has given you the permission, but local bodies don't want it. So the industries don't want to face these local issues, and that is why they go for this recycle and ZLD plants. At Thermax, I will share with you certain case studies. What we do provide wastewater treatment, recycle plants. We supply water treatment plants, sewage treatment plants, sewage recycle plants, seawater desalination plant, effluent treatment plant, effluent treatment and recycle plants, and of course now upgrade and improvement solutions. Because what we see is, suppose a plant is installed 10 years back. 10 years back, quality was different. 10 years back, outlet water quality requirements were different. So now, if suppose in the current year, if somebody wants to use it, their water quality might have changed, feed water quality. So and your outlet water quality requirement also might have changed. So the plant needs some upgradation. And of course, after Corona, a lot of people are going for automation, because Corona was the time when industry could not run many of these units because of non-availability of manpower in their factory. So now they are, and also they wanted to monitor. So we give centralized monitoring systems also for plant. We are right now monitoring a plant which is, say, in Delhi, and we are sitting here. So all the data comes to our screen, wherein what is it happening in the different treatment units of that effluent treatment plant or a recycle plant, and what is it that can be done by the operator to smoothly operate the plant. But let me just be with today's topic. I will just share some case studies. This is one case study. This is I have taken from Urban, wherein the client's objective was to minimize the fresh water intake. This is only one plant I am taking as an example. We have plenty of plants similar to this in Bangalore, Hyderabad, Gurgaon, or nearby Noida area, wherein there is a lot of water shortage, and government has given permission for these complexes, offices complexes, based on they will recycle maximum amount of water, and only a certain amount of water will be given to them for from outside. The typical characteristics: this is a commercial building. The plant capacity is 1300 meter cube per day. That means it is equivalent to 130 tankers per day. So you can understand each tanker will cost them 1000 rupees, and also there will be a lot of tankers which will be coming in that complexes which the industries don't, which those housing commercial buildings don't want. These are the IT offices with many restaurants in that area. So the feed water quantity and quality was 1300 meter cube per day plant. pH was 6.5 to 8.5. TSS was 200 to 450 ppm. COD was 300 to 1000 ppm. BOD 100 to 400 ppm. Oil and grease 50 to 100 ppm. And hardness 200 to 300 ppm. And total nitrogen 75 ppm. As most of you might be knowing that initially when the government laid norms, they had a norm of only BOD and TSS to be disposed. But over a period of time, when it moves towards the recycle, they are continuously making this norm stringent. For an example, some years back, this 30 norms for COD used to be equivalent to around 100. But now they are not accepting, even if you are recycling, they want you to meet this norm as 30. Earlier, there never used to be a norm for total nitrogen. In the domestic sewage or this, say, commercial building sewage, where the nitrogen levels are high, nitrogen needs to be brought down to less than 5, because as you know that approximately 1 ppm of BOD can create a oxygen demand of 1 ppm. But if it is ammonical nitrogen, that will create a oxygen demand of 5 ppm. How relevant it is? Suppose you dispose of this water into a nearby river. Only BOD will reduce oxygen equivalent to 1 ppm of oxygen equivalent to 1 ppm of BOD. But if 1 ppm nitrogen is present, that will create a oxygen demand of 4 to 6 ppm, 4.6 ppm. That means that will reduce the oxygen faster than BOD, which is not good for the aquatic life. So that is how, when they say that you reduce the pollutant, that means TSS less than 5. This TSS, how important is this TSS? Suppose they are not able to recycle and they dispose it into the river. This TSS will settle at the bottom if it is higher. And again, at the bottom, there will be anaerobic activity because of these. COD, when initially it was COD, that means even if they are recycling, water is having oxygen demand. So what will happen in the storage tank? Water will smell, because there is no process of aeration across the building. Means water is going to be stored in if it is a 10-story building, water will be stored in the underground tank, then it will be pumped to the overground tank, above ground tank, and in all these tanks, aeration is not possible. So what is possible is they are asked to reduce this organic matter to lower level, and be rest assured that these are norms which are not going to stay for longer. These are going to be further made stringent. BOD less than 5, oil and grease less than 2, hardness. Now this total water was 1300 meter cube per day, and their water demand was first was for flushing, second was for gardening, and they have a chiller system. So for that, they having a cooling tower, they need a makeup water for the cooling tower. So the same water was treated and supplied for that cooling tower. So if the water quality is not good, their cooling tower will get affected, their gardens will get affected because there's going to be smell. So this was the permission government gave it to them, that you have to meet this water quality. And each of these plants are designed based on what is it that you will come into the plant and what is it you are going to deliver. This is the typical scheme which was given to similar plants. Coarse screen to remove the coarse matter. Then you saw that there is a lot of oil in the water, 50 to 100 ppm, which is coming from eateries. That oil will be getting separated. Then because this is a commercial complex where people will come based on the shifts. So based on the shift, the sewage will be coming in. So it needs to be having an equalization tank. Now here, because the quality became stringent, the requirement was to have a membrane bioreactor in place. The membrane bioreactor had helped us after biodegradation, filtration of suspended matter and reducing the outlet pollutants. There is a pre-anoxic reactor. How it helped? The inlet water was having around 75 ppm of total nitrogen. So in pre-anoxic reactor, around 70 to 75% of nitrogen was removed by operating it in anoxic condition. The water was led to aeration tank. In this aeration tank, whatever the BOD and ammonical nitrogen was present, it was oxidized in a oxidation and nitrification process. The part of the water was recycled back into the pre-anoxic tank to recycle the nitrates, which can get converted to N2 there. And after in the post-anoxic tank, because pre-anoxic could remove only 75% of the nitrogen, post-anoxic helped in bringing it down to less than 5 ppm norms of total nitrogen, which government has laid. During the process, nitrification process, because the pH goes down, there was a provision of alkali dosing. And after aeration tank, it was the BOD and COD is reduced. But so there was a carbon source which was added so that it meets the carbon requirement for anoxic bacteria. Then there is a membrane tank wherein MBR modules are there, and a permeate pump which will suck the water through the capillaries of the MBR and put into the permeate tank. Out of the permeate tank, there are two lines. One line going to the softener, which can meet the low hardness, which can produce the low hardness water for the requirement for the cooling towers and the chillers, and the balanced water was used for flushing and gardening. So by doing so, what they have achieved? They have achieved that out of 130 tankers, at least 129.5 tankers can be produced internally. So their water demand from externally is only 1 water tanker per day. What are the benefits they got? Saving of tanker water cost. One other thing which I have not mentioned, every time a tanker enters, so the security needs to do some entry. Every time tanker goes out, it needs to do an entry. Then every time the tanker goes to the basement, there is lot many tankers which are going, it is inconvenience to the office people. That is not mentioned here. They are not dependent on external water availability. So if the external tanker is not available, they can still manage it. They are meeting the compliance with respect to government permissions. The government has given them the permissions that you will not be given more than 10 or 20 meter cube per day, which you are losing as softener reject or in the sludge. So they are meeting that. It is an environmentally clean solution because they are not disposing even a single drop in the river, and they are not facing any local issues. There is another case study which I thought I'll discuss with you, but in between, if anybody has any question, you can ask me.
Sir,
Yeah.
is it not possible to use any artificial intelligence in identifying these various parameters? There are so many parameters. Every time after treating, it cannot be checked.
Yes, very good question. So I have shared with you that now online monitoring systems are in place. So all the critical parameters are monitored online. So for whatever is right for sewage treatment plant, I'll tell you what is important there is to have pH, TSS, COD, and BOD. All these plants are having online analyzer at the outlet, and these plants are many of these customers those want to online monitor, or to many of the customer where pollution control board has said your data should come to my server. They have these online monitoring systems in place. So all this data goes to their server. But yes, there are certain parameters for which online analyzers are available, but because of high cost, industry or these IT complexes or housing societies don't install it. And I have already shared with you, Thermes is providing solutions like IoT solution, wherein we will have our sensors installed in your plants, means in an industrial plant, and all the data will come to my server. And based on that data, which is coming based on the analyzer, may it be pH, TSS, BOD, COD, TDS, hardness, whatever that data is coming on my server, they will observe that at these stages, this is the data coming, there may be something wrong in the plant. And they give them the technical expertise. What is it that you can do in this condition to eliminate these issues? Do I have I answered your question?
Yep, sir.
So I'll share with you one more example wherein client didn't had any pressure with respect to disposing the treated sewage, but it is a multinational. So what they did something for with respect to zero liquid discharge and ZLD only to avoid the local issues. This was a text. Their only objective was environmental protection and avoiding local issues. This was a textile dye house, and they already had an effluent treatment plant. I will share with you a scheme that typically the effluent treatment plants of a textile unit have got around 400 to 500 BOD, and you can say around 2,500 to 3,000 COD. But TDS levels are very high. So to our plant, the wastewater was treated. Wastewater was coming, means that the water was treated in their existing effluent treatment plant, and that is giving us the water. The capacity was huge. It was approximately equivalent to 375 tankers every day. So for them, they could have disposed of the water easily. The plant is in Ambasamudram. It's a very green area. It's a hilly area. If they want to save the money, they can easily dispose of. But there are local issues, so they decided, no, we will be recycling this treated water. This was the scheme which they followed. This was their existing effluent treatment plant. First unit as such in every effluent treatment plant is core screen, then an oil trap, then flow equalization, because there will be many fluctuation in the quality and quantity of the feed water, which will be absorbed, and the downstream process will be operated at a constant flow. Then they were separating the colors and by using coagulants and flocculants in a flash mixer and settling all that sludge into the clarifier. A lot of sludge was going to the screw press. Whatever the color they have removed and the suspended matter which they have removed from the water, it still had a lot of BOD COD. So they passed it to a aeration system, wherein they have got surface aerator, and they are maintaining MLSS around say 2,500 to 3,000, which is helping them further reducing the BOD COD, passing through a filter, disinfecting it, and after this, the water was coming to our recycle plant. And this was our recycle plant. We had an auto self-cleaning filter, basket strainer, water going to EF skid, RO, feed tank. Now you can see RO1, permeate is going, means good water quality, water is collected into a tank. Reject is going to RO2. Good water is collecting in permeate tank. RO3, good water is collecting into permeate tank. So what they have done, by putting 3-stage RO, they have increased their recovery. And the concentrate is going to reject tank and ME and ATFD. So in this plant, out of 3,750 meter cube per day, they could recover 93-94% of the water. And what it helps them in reducing the capacity of their ME. because the bigger the capacity, the more the water you are evaporating, your operating cost is very high. So this gave them a sustainable solution by having a low water cost in the inlet, at the same time reducing their evaporation costs. We are further discussion with them, so that we can further reduce their operating costs. I would like to share with you here a very interesting case study. There were about 20 odd textile units. So far, we are only recovering the water, right? But there were some 20 odd textile units, small units. They could not spend much of the water, and they were disposing this treated effluent to in a common effluent treatment plant. And as such, if all across India, the common effluent treatment plants are mostly not working. But here they did something differently. What they did, they spoke to all these textile units that to use the similar type of dyes, to use the same salt. So how it worked out beneficial for them. They treated the wastewater. They used to pump the wastewater having a meter into the common effluent treatment plant. And the amount of water each industry supplied to this common effluent treatment plant for treatment, equivalent amount of treated water they used to get back for recycling into the process. And the important thing here is, whatever was the salt recovered from their dryer, that salt also used to be given back to these industries for recycle. So this was a true, you can say, zero liquid discharge plant and zero solid discharge plant, wherein they recovered the complete water and also they could recover the salt which they could use it. So these are the type of things solutions which are coming in the industries, which industries is using because they are recovering some money out of it. The benefit to this particular customer was they were not dependent on external water availability. They were meeting the compliance. The solution was environment friendly from them because all around was a green area and they were not disposing this effluent into that. And of course, their main objective was met, that there were no local issues. Now, I'll share with you one more case study. But before sharing the case study, if you have any question, you can ask me. Okay. I'll take you through a case study. Yeah. Yes, you can ask me.
Sir,
Yeah.
any chronic health issues, as you said, the locals will also have some feedbacks from this
Yes.
treated water. What
Yeah.
in case if it is a chronic long-term illness that is caused because of those pollutant impacts?
See, I have shared the case study with you wherein previously they were disposing, but then they stopped disposing any water droplet outside. They were recycling the complete water into the process. Process like their production unit may have a requirement in the actual dyeing process. It may have a requirement in the boiler. It may have a requirement in the cooling tower, from where it is not going for any living being consumption. Let it be a human being or an animal. It is not going for any consumption. So there is no, impact on the human beings and living beings because of this. And plus, the treatment stages are so many that water is getting produced by every stage. And I think many of you might be knowing already. See, Singapore, they are using treated sewage. They are filling it in a bottle. That bottle is water is called new water. What they are doing is they are having multiple stages of treatment. And by applying new technologies there, they are able to produce the water which is as good as fresh water. And they are able to sustain. So in this case, because the treated wastewater is not disposed to the land or outer water body, there is no question of any diseases to them. Have I answered your question?
Yeah, sir. This is only with regard to your technology. What I was telling is about common treatment plants which are not operating properly.
Yes, that is impacting. That is why. Okay, so now I understood your question. The common effluent treatment plant, which are not treating it, now they are also being forced year by year to improve on the technologies so that they are also able to meet the norms. This is a problem, but yes, people are working on those technology. Means industries like us, companies like us are working on those technologies to produce good water from CETP effluent, and they are also forced now to treat it. I will share with you one solution which we have tried and tested in a common effluent treatment plant to so that the water can be recycled.
Fine, sir.
I'll take you through a case study. It is from a dairy. In dairy also, they have milk processing, they have yogurt, they have juices, everything is there. So every time the production changes, a lot of wastewater is generated. So here what we do, they make milk, yogurt, and other dairy products. Dairy product, cheese, they are making cheese, they are making casein, and out of this, a lot of wastewater is getting generated. Initially, they were disposing it on land. I will not say land. They were disposing it on the irrigation land. So it was having high smell. Their ETP was not capable of handling high COD effluent. Their COD was very high. As such, dairy effluent, milk, curd, your paneer, whatever they make, the effluent has got a very high oxygen demand. It was having a groundwater contamination and irrigation was getting affected. Treated effluent quality was not consistent at all. Means today, if they are getting 100 COD, tomorrow it will be 250, another day it will be 300. There are a lot of fluctuations. And because they were disposing on land, irrigation land, and there were a lot of local issues. And then came a point wherein a lot of water scarcity. Now, out of this, then the company thought, we have water scarcity, we have got local issues, our treatment plant is not meeting the norms, and it is contaminating the groundwater. So, what is it that we can do? Because with groundwater contamination, what you used to have is, even if they are pumping out some borewell water, it used to be contaminated, which they can't use in the production. So, they took an action. This was the type of a quality which was coming to the plant. You can see, if in an effluent treatment plant, 4 lakh COD is coming in, 2,20,000 BOD is coming in. Instead of that, if you leave it on the ground, it will make the whole ground smelly and unfertile. If you leave in the river, all the fishes will die. And after the treatment, what we could maintain for them, the pH was 7.5 to 8.5, TS was less than 10, COD at that time 150. It was a plant which we had executed around 7-8 years back. BOD less than 10, and this is the water which farmers readily accepted for use into the gardening, or means irrigation. Their objective was waste to wealth. Means they had a lot of waste, they wanted to produce wealth out of it. So how they produce? They treated the anaerobic mother liquor anaerobically. It was having 4 lakh COD. So they produced biogas out of it. This plant was able to produce about 6,000 cubic meter of biogas, which is having about 65% to 70% methane, which they could use in the boiler. So how it helped them? Complete biogas used in the boiler, complete effluent treatment plant. Because see, if one stream is having COD of around 4,000 to 6,000, and another stream is having 4 lakh COD, and both are put into a plant suddenly, then what will happen? A plant will not work. So how it helped them? It helped them to stabilize their effluent treatment plant, get the water produced, get the biogas produced, which they could use in the boiler, and the farmers were ready to accept their water for irrigation. There was no smell if the treated water is put into the ground for irrigation purpose. These were the benefits. Revenue from waste. They could use the biogas. At the same time, farmers bought water from them, which initially they were not ready to accept. Less impact on fluctuation in the fuel prices. External fuel prices might change, but as long as you are using biogas as a fuel, these are not impacting you. Less dependent on availability of fuel. You might not be getting fuel from outside, but you are producing your biogas internally, so you are not dependent on the external fuel availability. Less carbon emission into the atmosphere. Recycled water could be utilized for non-critical applications, and there are no local issues. So with this, I'll just share with you that this plant was, when the plant was supplied, they could recover the plant cost in 1 year. And now whatever they are operating, it is free of cost. Because whatever the investment they had done, they could recover in 1 year by way of utilizing biogas and selling the treated wastewater. So this is one part of my presentation. So I request you, if you have any query, you can ask me. So far.
Sir,
Yeah.
can you suggest the best treatment process for the grey water without using the electricity?
Well, there are treatments for treating the wastewater without using the electricity. But what happens is, you might have heard root zone technology, right?
Yes,
so
sir.
In that root zone technology, people there used to be a lot of area required where these plants used to grow, water used to pass through those plants and in turn get purified. So it doesn't need any blower power. It does not need any evaporation power. It doesn't need any reverse osmosis power. But yes, land is required.
Right, sir. Thank you, sir. Thank you.
Are you able to see my new slide?
Not yet.
Not yet, sir.
So do I need to reconnect?
No, sir. Again, try to share the slide.
Yeah. I'll first share the slide. Anna? Just
Yes,
one.
sir. Yes, sir.
Is it visible now?
Not yet, sir.
Just 1 minute. Is
Nope,
it visible
sir.
now?
No.
I think it will be. I've just shared it.
Yes. Now it is, sir.
Now it's there.
Suppose a water treated from an industrial
Sir,
effluent,
please,
The slide is gone.
slide is gone.
it is gone.
Yes.
1 minute.
But it have came.
Now,
Not yet, sir.
yes, 1 minute. I'll again share. Is it?
Yes. No, but
Yeah.
Yes.
Yes.
Yeah. So I'll just share with you about one product which we have developed considering this recycle point of view. Suppose there is a water which is well treated. All the parameters are within the norms, but it is colored. What is the likely possibility that you will use it. It is
No,
meeting
but-
all the norms. DOD is low, COD is low, TSS is low. Water is clear but having color,
Due to aesthetical reason, people won't use it.
right? So we
Yes.
have developed a product wherein water is having some color as well as it is having some COD. See, 30 COD is there, but it's still having some COD. There are many processes, like many industrial units like brewery, sugar plant, distillery, textile unit, wherein the treated water is having some amount of color. So for handling that, we have developed a solution in industry mainly for polishing. Activated carbon used to be used, but this activated carbon having pores which is absorbing the COD, and after some time you need to change it. So we have developed a media wherein this COD and color goes on the active sites of this media, and there is a oxidation happens there, because of which the pores are not getting choked. It's a filtered water we have to put in, and we can regenerate it by the chemical. And in the chemical also, it is not like that 100% of the COD or the color which has retained over a period of time, maybe a day or two, it will come out, because it is getting oxidized inside the media site. The regeneration waste also is not having so much of a color and COD, and it can be put back into the effluent treatment plant inlet. It is called pure code because it removes the COD. It purifies the water with respect to COD and the color. Of course, the standard primary treatment, secondary treatment needs to be used because it is a polisher. It can be used also for higher amount of BOD COD also. We have already installed a plant wherein the inlet COD, outlet COD at the outlet of a treated industrial effluent treatment plant was 1800 ppm. But the government had given them the permission for disposing 250 ppm COD. So this unit is working for more than 1 year, wherein they are consistently disposing less than 250 ppm COD at the outlet. So what this unit has done, this unit has given them the benefit with respect to one, large area not required for further treating the wastewater biologically. Large civil volumes not required. I'll show you the compact photo of this particular plant. It was a small plant, 100 meter cube per day plant. But that if suppose I had given a biological treatment, it would have required around 350 meter cube tank, which is a big tank. Also, a clarification system, plus blower, all these things were not required there. This is a typical scheme. This is a typical scheme. Treated wastewater is collected, passed through this pure gold media filter from top down, and after say 20 hours or 40 hours, based on the feed water COD and the color, it is backwashed and then regenerated using a chemical. So whatever the media there is, that whatever the excess COD is retained by this media, whatever the excess color is retained by the media, that comes out, and that can be sent to the effluent treatment plant. It's a very, very compact plant. For this particular plant, I will show you the photograph. What is the plant? This was the size of the plant. Very small filter, media inside. In one of the plant, this was the color. And when this type of a color is coming out, they could use the 100% of the water in the production. So many plants wherein the inlet treated water COD, many times you can't do anything about it. COD is say around 300, 400, and the BOD levels are very low. So even the biological system will not do anything. Then you'll have to go for costly ozonation system sort of a thing, or advanced oxidation. In place of that, a small media filter after the existing filters can be used for removing this color. I'll give you an example. We have a plant in Mumbai wherein it is an hospital. Very less space available. Their requirement was to reduce the tanker water cost. That plant was about 120 odd meter cube per day. That is equivalent to around 10 tankers. for last 2.5, 3 years, they have not bought even one tanker from outside. So they recovered their cost within a couple of months. So these are the treatment things. This is not applicable only for sewage. This is also applicable for industrial wastewater treatment. I have one more photographs I'll show you. This was the color at the inlet of this pure coat system in one of the plant's resin units, and this was the color at the outlet. So this complete water was going into the treatment plant. This plant had two-stage a primary treatment followed by two-stage biological system. All the parameters at the outlet were within the norms, but this was the color so that they could not use it. So initially they thought of having a RO plant, a UF plant, but then this is the solution what we provided. If only the color is the problem, then we can remove by this unit. So as you must have seen in all these case studies, that there is no common one solution for each and every application. What we do when we give this solution, we try to understand what are their issues, what are the feed water parameters, and what is it that which unit operation we can use it. If places where the BOD COD levels are high, I have to give the biological system. For the places where BOD COD is in the limit, but the TDS levels are high, I will have to go for reverse osmosis system. For industries where treated effluent TDS is also high, colloidal silica is also high, colloidal other matter is also high, I might have to give a ultrafiltration system and a RO system. Yes, we have got all the solutions here to provide to the industries, and we are still working on various new technologies which we can provide to the industries and for the domestic application to meet the main goal that the water should be recycled and it should be a completely zero liquid discharge. If you have any question, maybe you can ask. This solution we can provide it to steel industries, refineries, pharmaceuticals, chemical industry, and fertilizer, and we are the first to provide it in India. Any questions from your side? I'll be very happy to take the questions. This is the end of my slides.
No, sir, it was very nice presentation and it was a very detailed explanation. So there is no, I think there is no need to ask anything and everything is discussed. So nice of you, sir. You explained it very, very well, sir.
I'll be very happy to answer any questions, and I can share my email ID also. Also, you can share the email ID with the participants. If they have any question, you can mail it to me. You can contact me on mobile. I'll be very happy to answer.
Sir, there are several developments in the wastewater treatments also. There are combinations with membrane separations also.
Yes.
But I will discuss you separately through our email, sir. I will take your email.
And what is happening is we are not stopped here. Our R&D team is continuously working.
Yeah.
And they are working on the problems of the industry and giving them the solutions.
So maybe there is a possibility that I may suggest you one solution apart from existing.
Yeah.
Okay, sir. Thank you, sir. Thank you, sir. Good night.
Thank you very much. Thanks to.
Any other question? You can also type your questions in chat box. We'll take those questions.
Sir, I have one question.
Yeah.
So I had been to one presentation where so the expert talk about disposal problems with membrane technology. So is there any work going on in that area? So after membrane life is expired, so its disposal is a big issue.
See, we have to choose between two things. One is how much water I can recycle within the given life of the membrane, right? Suppose I don't have a membrane. For an example, I am taking, suppose the plant requires RO plant and I don't put it. Then I have a problem in hand that I need to dispose of that treated water. I can't recycle it. So there is always a balance between, what will I do once the membrane life is over and how much will I save if I recycle the water. But definitely there are, if I talk about Thermax, Thermax was the first to install a zero liquid discharge plant in 1998. When people never used to think about only treatment, we had supplied a zero liquid discharge plant at Arvinville, Santej. Now, if you talk about the membrane suppliers, they will give you a warranty of about, say, 3 years. But there are plants, if you are maintaining well, you can extend the life of the membrane to, say, 4 years or 5 years. But yes, after that, definitely it has to go to a dumping site as per the recommendation of Pollution Control Board for disposal of waste from the plant. See, in any case, suppose there is a textile plant, they will be disposing a lot of clothes, which are colored cloths used for cleaning of dyes, cleaning of floors. So they give the permission for disposal of. So it has to go to a hazardous facility, wherein incineration system will be there, or there will be some system by which they will be able to handle these membranes. So yes,
Thank you, sir. Thanks for
problem
the
is there,
answers.
but they are able to. Yeah.
Okay.
Thank
Thanks.
you.
Thanks a lot, sir. Very nice presentation.
Thank you.
Any more questions? We still have time, so any more questions? It's welcome.
Any question with respect to whether I have covered it in the presentation or not covered it?
Hello, Tagokar from Nagpur.
Yeah.
Am I audible?
Yes, you are audible, but sound is not.
I
that
just
clear.
want
It's
to know
both.
that you just go through that slide where you said that you use charcoal for removing the color.
It
I
is-
just want to know.
Yeah.
I just want to know whether it is commercially available or it is on just a pilot study.
No, I shared with you that we have installed a plant of around 120 meter cube per day in a plant which is removing COD up from consistently from 1800 meter cube per day to 250 meter cube per day. It has been
Okay,
commercially
but-
installed. And it's not a
but-
charcoal.
Okay.
It is not a charcoal. Okay, it is a
It is-
specially media developed by organization wherein there are active sites wherein oxidation also takes place. In charcoal, oxidation doesn't take place.
So what it contains, sir? That media what
Yeah.
contains?
It's a patented media, ma'am.
Okay.
There are certain
No,
details I will
it
not
means
comment.
well, I'm a microbiologist and my work is on the reduction of hexavalent chromium. So that's why I'm more inquisitive about that particular topic. Is it
I just-
bacterial media?
No, I'll just tell you. It is this media you can use only for COD removal. This
Okay.
will not be. They have different medias available, wherein the work is going on for silica removal. There are different medias available, but this particular media which we have commercially tested, commercially used, I am sharing with you. It is only for COD removal and color removal.
Okay. Thank you, sir.
Okay. Yeah.
Sir, what is the residence time for the removal of COD and color?
Where? In biological system or in the polisher?
Sir, in the filter unit where you are having that cylindrical filter unit, you are
no.
passing through the colored water
Yeah.
along with the highest COD of 1100 to 1800.
Yeah.
What time is required to reduce that? How much time it takes, residence time?
It's a good question. The only one aspect with respect to this is that it depends upon how much PTCO color unit is coming inside. There is a plant wherein one single vessel could help us. There is a plant where I need to implement 2 vessels in series. But if I talk about sewage application, it is very, very less because the filter size is, I will say around 10 to 15, not even 10 minutes. It is a flow through. It is not a batch wise process. Water in, water out. Like we give dual media filter or a pressure sand filter, it is a similar filter. Because the principle is different. Principle is not only filtration of suspended matter. The active sites on the media absorb this color, oxidizes it, and it is a regenerative thing. So, like normal filters, we which are regenerated means put into practice again after backwashing. In this, we have to regenerate. This is the only regenerative media present in India.
That is fine, but 15 minutes of time is enough for
It is more
removing
than we have tested. I am saying 15 minutes is also more. It's hardly any time. Water in, water out.
Wow, that's nice, sir.
So it's a
Sir,
not more than 5 minutes. It'll take. It is a continuous process. It is not a batch-wise process. Yeah.
excuse me, sir. Can we mix this water in resources, other water resources, other water bodies,
Like.
like river or anything?
Yeah. See, once you have removed the color, once you have met the parameters as per the disposal norms, you can definitely do it. How government sets the parameters for a particular area, depending upon what is the water condition in that river body wherein you are going to dispose of. Suppose your river is already dry, and I am mixing high COD water in that. What will happen? The resultant COD in the river or resultant pollutant level in the river will be high, which will not be good enough for human beings or animals. So it depends. But normally, whatever if the plant is producing 30 COD, good enough to mix in the river.
Okay, means it is good for it is not that much bad for the water ecological system of the water.
No, not at all.
Okay.
I'll say here differently.
Okay.
It is more harmful if you put a glass of water into a glass of milk into the river than putting this water.
Yeah.
Because if you're putting a glass of milk in the water, that will produce more COD, more oxygen demand than this 30 COD water.
Yes, sir. Okay. Thank you, sir.
Thank you.
Sir, last one more question. Like, is this the only filter that you are using, or are there many other
No, there are
filters
many.
for
There are many
various
other-
other parameters?
No, there are many other filters. It is based on the application. I have only shared with you one particular filter which we have launched commercially for COD and color removal application.
Okay, because
What we found, what we found that when the water is being passed through activated carbon filter, it is not removing the color in the COD to that extent. But this is helping us.
my question was here with respect to color itself. Like, color is made through dyes, and dyes are made by heavy metals.
Yeah.
How come heavy metals are also removed through this?
See, heavy metals is not removed through this. Dyes are not only removed through, what color we are talking about, textile, whatever the degraded into the, first color removal into textile process in the primary treatment. Then after removal of 70 to 80% of the color, it goes to the biological system. In biological system, it further gets reduced. Then you are dosing some oxidizing agent. Then it is going to this. It is a polisher for textile industry. But there are many CETPs wherein textile effluent is coming, and it has been tested on lab scale. It is giving absolute colorless water. I shared with you a case wherein the COD levels were 1800 ppm. Initially, we also had a doubt whether it will reduce such a high COD or no. But by following our SOPs and operating this for more than 6-7 months, it is consistently giving less than 250 COD. The product was new. Here, I would like to share that this was new, but yes, it has to be tried at some places. So luckily, and by testing at various places, this place it worked out, and many other places it is under installation now.
Sir, I have one question regarding this media which is prepared there for this color removal. So it is porous in nature. So what about the efficiency of that as we are going to use? Is there any falling phenomena or concentration polarization is taking place?
No. It doesn't happen there because see, I have already shared with you that dual media filter works on a different principle. Activated carbon filter works on a different principle. In dual media filter what happens is that whatever the suspended organics are there or suspended inorganics are there, those are only going to get removed. In this type of a plant, what happens is there are active sites on this media which absorbs the organic and it oxidizes that.
Okay.
But in future, maybe if we are able to meet next time, I will be able to share a couple of more medias which have been used for some other application. It is going to happen. because
Thank you.
industry basically looks for solutions which are compact, which are cost economical, and our R&D team continuously works on that.
Yes.
I've shared with you this particular media. I would like to share with you in this particular plant where we have commissioned it and operated it. We needed regeneration every second day, but we have used it for a resin application. Even for 1 month, we don't need to regenerate it. So it also depends upon what is the organic matter which is present there.
Correct.
So,
Yes.
and what we do basically is we first test for that particular application in a small, you can say, lab unit. We have designed lab units also for that. I'm not talking about pilot unit. It is a lab unit. So once it is tested at site and we are sure that yes, this will work for this application, and then we supply that. And in lab scale, it has shown very, very encouraging results for many units other than the 2 units which I have just shared with you.
Yes. Any more questions from the participants? Okay.
I think there's one question in chat box. I don't know. Just 1 minute. No, not so far.
It gives me immense pleasure to propose vote of thanks on today's session. Thank you, sir, for your interactive and interesting, insightful presentation on different waste management policies, practices, then 3 keys of sustainable waste management, then typical process of recycled and ZLD, and as you explained, the case studies or applications for total water management for domestic as well as the commercial resources, then industrial waste managements, including case studies as you explained for the textile, dairy, then interesting that pure coat media developed by the Thermax. So it was totally a very interesting session. And I think all the participants also enjoyed this. So your expertise really added value to our FDP. On behalf of School of Engineering, Management and Research of D.Y. Patil International University, I express my sincere gratitude for your time and contribution. I
In
thank
fact,
you all participants and all the organizers.
Thank you,
Thank
sir.
you.
Thank you so much. Participants, the feedback link is going to get posted into the WhatsApp group. Do fill your feedback form. Thank you, sir.
in fact,
Thank you all.
In fact, thanks
Thank
from my side, for D.Y. Patil team and all the participants who have participated in discussion with me during this presentation. Thank you very much.
Thank you, sir. Thank you so much. Yes.
Thank you and good night, sir.
Good night. Thank you very much.
Take very good care of yourself.
Oh yes, thank you very much. Same to you. Thank you.
Now I request all the participants, you can leave the meeting. The
I can
today's
log
session
off?
is over. Yes, sir. Yes. Tomorrow we'll be
Thank you.
meeting same time, 6 p.m.